In this video, we're going to talk about derivatives of trigonometric functions. And for our objectives, we're going to find derivatives of basic trigonometric functions. We're going to find higher order derivatives of basic trigonometric functions. And we're going to review all rules of differentiation. I don't have a good blank copy of these notes, so I'm going to just talk through the one with all the work written out that we did from class already. So let's go ahead and start with this theorem that the derivatives of the trigonometric functions here that you need to memorize, and these come in three sets here, three pairs, is that the derivative of sine is cosine, the derivative of tangent is secant squared, and the derivative of secant is secant tangent. Go ahead and memorize those first. Then there's a pattern that you can recognize with the cofunctions. Since cosine is the cofunction of sine, we're going to take the cofunction of the answer over here, and we're going to put a negative in front of it, multiply it by -1. So the cofunction of cosine is sine, times a -1 is a negative sine. The cofunction of tangent is cotangent, the cofunction of secant is cosecant, and we're going to multiply by a -1 here. So secant squared becomes cosecant squared, and you multiply by -1, it's a negative cosecant squared. The cofunction of secant is going to be cosecant, cofunction of secant is cosecant, cofunction of tangent is cotangent, multiplied by a -1. It works both ways. So if somehow, some way I memorized that the derivative of cosine is negative sine and didn't have that the derivative of sine was cosine. So I'm going to take the cofunction here of cosine is sine, the derivative of sine is cosine, multiplied by a -1, and I get rid of the negative, and the cofunction rule for derivatives goes both ways. So just memorize that these are inseparably joined together like that, and that they are related to each other. All right, let's find the derivative of y equals cosine of x plus sine of x. To do that, we're going to take the derivative of each part separately and add them together. So the derivative of cosine is negative sine. The derivative of sine is cosine. Add them together. It's just as correct here to say that this is cosine minus sine. That's good too. We're doing that directly from the formulas. The derivative of cotangent is negative cosecant squared. The derivative of tangent is secant squared, and it's a difference there. Now this one's a little trickier because we have a product rule going on here. So derivative of sine is cosine, but we're going to do an aside here for the product rule. I would call this u and v, but I'm going to go with what's written on the paper here. So you have u prime v, and then you have this is g prime v prime u, like that. So that's fine. That's going to be 1 times cosine plus v prime u, like that. So this is going to be cosine minus x sine. That's going to go back in place of the star here. So we have cosine of x minus this quantity, cosine of x minus x sine x. We distribute that negative there. That's a negative cosine plus x sine x. These zero each other out, and we get x sine x is equal to y prime. Now let's deal with this quotient, and we have a u over v situation. Again, in class we did f over g, so let's go ahead and do that. Derivative of f here is going to be cosine. Derivative of g is going to be negative cosine. Write out the quotient rule here, that this is u prime v minus v prime u all over v squared, so you get it right. So u prime v minus v prime u all over v squared. And then we're going to go ahead and distribute here. Cosine minus sine cosine. And then this is going to be negative cosine minus sine cosine. Distribute that negative through. And we get this cosine minus sine cosine plus cosine plus sine cosine, sine cosine, and negative sine cosine zero each other out. We end up with a 2 cosine x in the numerator. We have a denominator of 1 minus sine x quantity squared. All right. Let's go ahead and look at our next example where we talk about the derivation of how do we get the derivative of tangent with secant squared. Let's use the quotient rule and talk about tangent being sine over cosine with our quotient identity. So if we have the numerator as sine and the derivative of the numerator is cosine, the denominator is cosine and the derivative of the denominator is negative sine. We're going to have our quotient rule tells us to take the derivative of the numerator times the denominator minus the derivative of the denominator times the numerator all over the denominator squared. So we're going to end up with cosine squared, and then this is going to be minus a negative, it's going to be a positive, plus sine squared over, and then the denominator squared is going to be cosine squared. With trig functions, we go ahead and we write that squared next to the function name, so it's obvious that there's 2 of the entire function, not 2 of the variable that's inside the trig function, because we know people won't write the parentheses and will be ambiguous and say the wrong thing and say, well, you know what I meant. Well, write what you mean, right? That you have 2 cosine functions, not 2 x's inside of the cosine function, because that's what it would look like if we didn't put those parentheses there. And we want to be absolutely clear when we're communicating with people that we have 2 cosine functions. So that's why we raise cosine to the power of 2. It's kind of a unique way that we write things, but there's a method to our madness. All right, so this is the same thing as 1 over cosine of x all raised to the 2nd power. Well, 1 over cosine of x is the same thing as secant of x because of the reciprocal identity. And again, we write those powers of trig functions on the name of the trig function. So secant x times secant x becomes secant squared x, and we say it that way. But do not forget this Pythagorean identity and any of its variations. Remember that sine squared x plus cosine squared x is equal to 1. 1 plus tangent squared x is equal to secant squared x. And that 1 plus cotangent squared x is equal to cosecant squared x. All right. Those are all your Pythagorean identities that are fundamental identities from pre-calculus that you need to remember. And that's it for this video. We'll come back next time and talk about the chain rule, which is how we deal with compositions of functions and when we take derivatives of compositions of functions. All right, see you for the next video.